the sky. We see them flying free. That's just like you and me. Everyone is lonely sometimes, but I would walk 1,000 miles to see your eyes. You are not alone, we are family. Hold me, let's escape all this reality. You are my symphony. By your side, we are united. You are my energy, my guiding light. We are unity. We are unity. Although the rain might part, a thunder starts to roar. The lightning waves.
Hello everyone. You're welcome to yet another edition of OS e-learning platform. And then today we have a simple discussion on a theme: electricity and electromagnetism. But before we get a discussion, let's first pray. Jesus in Christ, we believe that whatever we pray through your name, we surely receive. Pray for wisdom, knowledge, and understanding. And as per this discussion, guide us, Jesus. Be there for us and be there in us. For we believe with you, who strengthens us, we are in position to do everything. Viewers, you're welcome. Let's have a discussion on this topic: transformers. What is a transformer? Have you ever come across a transformer? Yes. Where have you ever seen a transformer? So basically, throughout discussion, we are going to respond to very many tasks that require us to talk about as far as transformers are concerned. And just in case you encounter any scenario that requires you to digest, that requires you to talk about transformers or a transformer in particular, I hope throughout this discussion you will have something, and on that particular time you will be in position to share that. So the key points to discuss today, we need to know what a transformer is. What is a transformer? We need to know the structure and or action or how it works, types of transformer, transformer equation, energy losses in the transformer, and finally, how to reduce the energy. The transformer. So basically, a transformer is a passive device that is electronic in nature, and its role is basically to transfer electrical energy between two or more circuits. And this is done through a process called electromagnetic induction. Electromagnetic induction. So a transformer is a passive device that transfers electrical energy between two or more circuits through electromagnetic induction. Primarily used to set up or down, meaning we primarily have two types, that is the set up and the set down transformer. So their role is to set up or set down the AC, the alternating voltage. It consists of a core and two or more coils. That's the primary coil and the secondary coil that are electrically isolated but not magnetically linked. Another alternative when you're defining a transformer is basically a static electrical device that transfers electrical energy between two or more circuits through electromagnetic induction. So the process is maneuvered through by electromagnetic induction. So it works on the principle of mutual induction or mutual inductance. That is, when the alternating voltage is converted from one circuit to another without any direct electrical connection between the two circuits. So this is manifested through a changing magnetic flux in the transformer's primary winding or coil. And this generates an alternating voltage in the secondary winding based on Faraday's law of induction. So the science behind all this knowledge of transformer is called Faraday. He put forward his observation, put forward his law as far as magnetic flux linking a certain coil is concerned. So transformers are mainly used to increase, that is setting up, or decrease, setting down. In other words, step up and step down voltage levels without changing the frequency of the power supply. So basically, it is decreasing or increasing the voltage. The structure and action, or how it works. So the structure, in other words, the parts of the transformer, we have the core, can be rectangular. So the rectangular core provides a magnetic path for the magnetic flux generated by the primary coil. The primary coil is connected to the input voltage source and it generates a changing magnetic field when an alternating voltage is applied. Then the secondary coil. So the changing magnetic field induced by the primary coil, induces a voltage in the secondary coil, which is the output voltage. So the transformer action. So the process of inducing a voltage in the primary coil by a changing the process of, I beg your pardon, the process of inducing a voltage in the secondary coil by a changing magnetic field is called transformer action, operating on the principle of electromagnetic induction. So basically, this episode gives us an in-depth discussion on a transformer, as in its definition, basically the few parts, that's the core, the primary coil, secondary coil. And then I have also its diagram here. So that is its diagram. We have the laminated core, primary coil, and secondary coil. The primary coil is the one connected to the supply voltage. And then the secondary coil is the one that's connected to the second circuit. So the first circuit is connected to the primary coil, then the secondary coil connects the second circuit. So the transformer acts as a mediator between the two circuits where an alternating voltage is subjected to. Types of transformer, types of transformers. Basically, we have very many types of transformers, but our discussion will basically zero on two types of transformers. We have very many, as you see down here, but we shall basically discuss about the two types. However, we have more than two. So the step up transformer, a step up transformer, that is a type of a transformer that increases the voltage from the primary winding to the secondary winding. Step up is like to increase the amount of something. So basically, the voltage is increased in the primary, from the primary coil to the secondary coil. This is commonly used in power generation to raise the voltage for the long distance transmission, and also it helps in the minimizing power losses. So this is a type of a transformer that is stationed in the base of the power generation point. For example, in the dam, when the alternating voltage from the turbines are converted into electrical energy, and then this energy is to be transmitted to longer distances. And for the case of Uganda, transmitted from the dam, then it is transmitted to all other countries almost surrounding Uganda, the long distance transmission. So it is enabled by the step up transformer. Another type is the step down. Step down to reduce. A step down transformer increases the voltage from the primary to the secondary winding. These are widely used in households to reduce the high transmission voltage, and also actually basically it is used to minimize the high voltage. Remember, some of the appliances, some of the gadgets used in the households are of a lower voltage, to the extent that we need a minimum level of voltage that can be so safe or safer to all these appliances. So we need to have a transformer. In other words, it is placed within the vicinity of the households. Other types will be isolated transformer. Another type will be auto transformer. Another one will be the three-phase transformer. The three-phase transformer. Just to go through them, an isolation transformer. An isolation transformer provides electrical isolation between the primary and the secondary circuits, often used in sensitive equipment to prevent shock hazards. Auto transformer. An auto transformer has a single winding that creates or that acts as both the primary and the secondary winding, offering voltage regulation in the applications like motor control. And then the three-phase transformer. A three-phase transformer is used in a power system to convert three-phase alternating voltage, AC voltage. These are more efficient than a three single phase transformer and are commonly used in industrial settings. The three-phase transformer, one of the powerful or the most powerful transformers. So basically, we shall zero our mind on the step up and the step down as per our scope. The transformer equation. So after realizing that the transformer is made up of two winding, two windings, that's the primary winding and the secondary winding. Meaning on the primary winding, you need to know the input current, the input voltage, what we shall call the voltage P, voltage subscript P. You need also to know the number of turns in the primary coil vis-a-vis the output voltage in the secondary coil, the number of turns in the secondary coil, and also the voltage in the secondary coil, what we shall call the VS, the output voltage. So the transformer equation relates the primary and the secondary voltages and the turns, meaning the ratio of voltage in the secondary to voltage in primary is equal to number of turns in the secondary coil over number of turns in the primary coil, where Vs is the secondary voltage, Vp is the primary voltage, Ns is the number of turns in the secondary coil, and Np is the number of turns in the primary coil. The energy losses in the transformer. The energy losses in the transformers. They are basically caused by very many factors, and below are a few of them that I've tried to highlight. One, copper losses. Resistance in the winding causes energy loss in the form of heat. Now, as this alternating current is flowing through the wire, the connecting wire or the copper wire, the core subjects a resistance to it, and this resistance gets into heating up the circuit, and that is a manifestation of energy loss but in form of heat. Another loss is iron loss. Basically it is because of hysteresis loss, and this is due to magnetic materials subjected to magnetization or demagnetization during AC operation. Now, as the alternating current is periodically changing its direction, the system or the magnet, the iron core is periodically magnetized and demagnetized. Uh, During this process, the energy is lost in form of magnetization or in the process of magnetization and demagnetization. And this energy loss is referred to hysteresis. Hysteresis losses. Eddy current losses. Induced currents in the core causes energy dissipation as heat. Now, as the EMF or electromotive force is induced due to the changing magnetic flux in the coil, EMF comes with alternating current. But this alternating current flows in such a way that it opposes the the voltage that is causing it. So the opposition subjected to it is in form of eddy current. So it dissipates this heat in form of heat. Flux losses. Some magnetic flux may leak out of the core, reducing the efficiency of the transformer. By the way, I will send you research also about the efficiency of the transformer. How do we calculate the efficiency of the transformer? And some numerical applications before I upload them. So take that as a point, note it. Kindly make research on the efficiency of the transformer in some 2 or 3 numerical applications. What I mean, the calculations. How can we reduce the energy losses in the transformer? Now that we've seen it's because of resistance, magnetization and demagnetization process, because of eddy currency. It's also because of flux losses. As some magnetic flux may leak out of the core. And for this, the proportional amount of magnetic flux that does not reach the secondary coil reduces the efficiency of the transformer. How to reduce? Number one, use high quality core materials. High quality materials, core materials. Employ materials with low hysteresis and eddy current losses. Laminated core. Why do we need to laminate? Reduce eddy current losses by using the thin isolated sheet of core metal. Optimize windings. Minimize resistance in the winding by using appropriate wire gauge. And reduce the length of the conductors. We are trying to minimize resistance within the winding. Proper coiling. Ensure adequate coiling to prevent overheating and reduce energy losses. And so many factors can be put forward, or remedies can be put forward to minimize the energy losses in the transformer. In other words, to increase the level of efficiency of the transformer. Well, thank you so much for listening. Thank you so much for watching. I wish you all the best. Kindly take care of yourselves. May God bless you as we share this knowledge, as we stay as a family. Of course, we are united. Thank you so much. I love you. Bye bye.